Welcome back. Let's do some more examples. All right, so we've got a couple of sets and we want to list the elements that are inside of, first off, a complement. So A has an A, B, and a D in it, and our universe has all the letters from A through F. So if I wanted to list A complement's elements, it would be everybody except for A, B, and D. So there would be a C and an E and an F. And for B complement, everybody not inside of B. B has C, D, E, and F. So everybody that we're missing would be the A and the B. All right, B complement, complement. So I've already found in the previous example that B complement has an A and a B in it. So now if we ask ourselves, what's B complement complement? What's the opposite of B complement? Who is not inside of B complement? Well, that would be the C, the D, the E, and the F. Or in other words, B complement complement would contain everything inside of it that B did. Which is not really a surprise. I mean, if we're thinking about it, that a complement means the word not. So this is sort of like a double negative. It's the opposite of B, which brings us back to B. For the universe complement, everything that's not inside the universe, that one is actually pretty easy to do if we think about it, because the universe contains everything. So what is not inside the universe? The answer is there shouldn't be anything that's not inside the universe. What is outside of our universe? A whole lot of nothing, the empty set. There is no elements that are not inside of our universe. So if you say, what's outside of the universe? What's universe complement? That would be the empty set. And the reverse, the empty set's complement. If you said, what are the elements that are not inside the empty set? It would be everything. Everything is not inside the empty set. Every single element in the universe. So what is the opposite of the empty set? That would be the universe. All right, let's do another example. This time we've got a universe and a bunch of sets, and we want to figure out who's inside of various sets. And again, we're going to be using step-by-step approach. So that means for something like A complement union B, I'm going to first need to figure out what A complement is. Then I'll be able to figure out what A complement union B is. So starting with A complement, A is the set that contains 2, 4, and 6, and my universe has all the numbers from 1 through 6. So A complement should have a 1, 3, and a 5 in it. And now, if we do A complement union with B, so everybody who's inside of A complement or B or both. So I've put in everybody that's inside of A complement. And then as far as what's inside of B, there's a 1 and a 3 and a 4. We've already listed the 1 and the 3, so we don't list them again. I'll just need to now add on the 4. So 1, 3, 5, and 4, those are the numbers that are inside of B, or inside of A complement, or inside of both. Okay, A complement intersected with D complement. We already have A complement, that's 1, 3, and 5. D complement, who's not inside of D. D has a 1, 3, and a 5 in it, so the opposite of D would be a 2, 4, and a 6. And now I'm combining these two sets with an intersection. So I'm asking myself, A complement intersected with D complement, what elements are in common? And I'm looking at the two sets that I have, and there's nothing in common. These two sets are disjoint. So I could say that A complement and D complement, they are mutually exclusive. They are disjoint sets. All right, I'm going to take this A union C complement and break it down into two steps. First finding A union C, and then I'll find the complement of it. So again, working my way from inside to outside. A union C, it's going to have everybody that's inside of A, and it's going to also have everybody that's inside of C and everybody that's inside of both of them. So I've listed A, 2, 4, and 6. C has a 5 and a 6 in it. The 6 I've already got. I just need the 5. So now, A union C complement. What is the opposite of the set that I just found? That set has 2, 4, 6, and 5. The only things in the universe that I don't have listed are 1 and 3. All right. One more. We've got an A intersect B complement union with D. So again, if we're thinking about how we're going to break this down into steps, I'm going to first think about finding A intersect B. Then once I know that, I can find A intersect B complement. Then once I know that, I can find the union of A intersect B complement with D. So let's start with A intersect B. What do A and B as sets, what do they have in common? A has 2, 4, and 6. And for B, 1, 3, and 4. The only thing they have in common is the number 4. So when we're looking at A intersect B complement, that would be everybody except for the number 4. That would be a 1, 2, 3, 5, and 6. And now if I wanted to take A intersect B complement and find the union with D, I would take everybody inside of A intersect B complement, and then I'd add everybody who's inside of D that I didn't already list. So I've listed A intersect B, 1, 2, 3, 5, 6, and now I'm looking at D, and it contains 1, 3, and 5. I've already listed all of that, so I don't have anything else to list. There we go. 1, 2, 3, 5, and 6. Those are the things that are inside of A intersect B complement, or inside of D, or inside of both of them. Just as a little side note, which is something you may have thought about just as we were doing this, we might have noticed we listed all the things that were inside of A intersect B complement, and then we noticed that D, all of its elements, are already inside of A intersect B complement. In other words, we might have noticed that D happens to be a subset of A intersect B complement. Not super important that you noticed it, but if you noticed that, good for you. All right, this one I'm going to need to break down into quite a few steps. I'm going to first work my way from the very inside, the innermost brackets, and figure out what B union C is. I'm going to also ask myself what A complement is, because then I'm going to combine those two things with an intersection. I'm going to then figure out what is B union C intersected with A complement. And so at that point, I'll have figured out everything inside that big bracket. And so the only thing left to do would be to say, well, now that you find B union C intersected with A complement, what's the complement of all of that? So take what I just found and find the complement of it. So it looks like I'm going to need 4 steps here. I'll start with B union C. So anybody inside of B or C or both. B has a 1, 3, and a 4 in it. And C has a 5 and a 6, and I've not listed any of them yet, so 5 and 6. So 1, 3, 4, 5, 6, those are the numbers that are inside of B or C or both. A complement, who's not inside of A? A has 2, 4, 6, so A complement, there should be a 1 and a 3 and a 5. And now I'm going to ask myself, B union C intersected with A complement. These two sets that I just found, what do they have in common? And what do they have in common? Well, they have a 1 in common, they've got a 3 in common, they've got the 5 in common, so 1, 3, and 5. So that's B union C intersected with A complement. And now, what's the complement of that? So now I want to figure out what is B union C intersected with A complement. And so I'd say, well, the previous set, B union C intersect A complement, there's a 1, 3, and a 5 in it. So who's not in that? Looks like a 2, 4, and a 6.